Perfect. Welcome, everyone. I am absolutely thrilled to have you here for the third episode of our webinar series PLOS Open 2.0. My name is Agata Morka. I am Regional Director Publishing Development for Europe at PLOS, and I am your host for this series. And this series is all about exploring the next big thing in open science with a special focus on Europe. So we've gathered innovators in the space of open science, and we will talk about emerging trends. So expect lively discussions, bold opinions, and hopefully a bit of friendly disagreement, because this is always where the real progress happens. Today's session is all about collaboration, and fittingly, putting it together was also a team effort. So the session is brought to you by PLOS, the Einstein Foundation, BIH QUEST Center for Responsible Research, and Berlin University Alliance. So thank you to all my colleagues who helped me with preparing this event. So now here is what makes this webinar series a little bit different. We have one strict rule: no PowerPoint presentations allowed. No one wants to look at slides. We always meet on Friday afternoons, which probably is the worst time slot you can think of, but also perhaps the best one to slide nicely into our weekends, enriched with this hopefully inspiring discussion. So let's jump right in. Today's topic: big teams, big problems, open science practices in collaborative science. So recent years have witnessed a significant surge in large-scale projects involving ever-growing number of researchers. So big team science initiatives break geographical, cultural, and disciplinary boundaries to involve thousands of bright minds across the globe to tackle pressing issues. So is it the more the merrier? Well, collaboration is one of the core foundations on which scientific research progress relies. But the scale and complexity of big team science initiatives bring unique challenges. How do teams of this magnitude manage communication, data sharing, methodological consistency? And finally, how are open science practices like sharing data, code, protocols, and methods being embraced by big team science initiatives? So let's unpack these questions together with our speakers. We have a stellar lineup today. I will start with Amy. So we have Amy de Bruin. She works at Open Science and L, which is the national program that aims to promote and accelerate the transition to open science in the Netherlands. And Amy works specifically on the replication studies call, and we will talk about this later. Fun fact about Amy: Amy studied classical languages and later switched to child and education sciences. An interesting choice. Next, we have Professor Anna Dreber-Almenberg, who's a professor of economics at the Stockholm School of Economics. So Anna is an expert in meta-science, behavioral and experimental economics, and she's deeply involved in replication research and the prediction of replication outcomes, contributing to initiatives like Lab 2 and the Institute for Replication. On a more human note, Anna really likes reading books about mountaineering, but has never attempted this herself and has no plans to do so either. Next, we have Kamran Naim, who is the head of open science at the European Organization for Nuclear Research, CERN, where he leads a diverse portfolio of activities that aim to set the standards of a future open science ecosystem. And last, we have Tracy Weisgerber, who is also a meta-researcher and physiologist working to improve data visualization, reporting on open and reusable methods and protocols, and other factors that affect transparency and reproducibility in biomedical research. Since 2024, Tracy serves as the Excelsior Project ERA Chair Team Leader at the University of Coimbra in Portugal. Other than that, back in time or in her past, Tracy did ultra cycling. So now that we know a little bit more about our speakers for today and our our topic, let us dive straight into questions. We will have 45 minutes to talk to our speakers, to our panelists, and then we will open up the floor to your questions. So please do not be shy, type your questions in Q&A, and we hope that you will also engage with our experts here. Anna, I will start with you. So, with your extensive experience in evaluating the credibility and reliability of scientific findings, how do these challenges manifest in the context of big team science initiatives? And even more so, how do open science practices, such as data sharing, transparent protocols, open methods, contribute to fostering credibility and collaboration in these large-scale scientific endeavors?
Great. So I'm actually not so sure that we have any big challenges related to big team science for these types of projects. So let me just try to explain very briefly what these projects entail. So these are basically big teams of researchers trying to perform replications or do reproducibility checks. So that sort of, in order to replicate many studies, we typically need to be many researchers having access to many different labs at the same time. We also do big team science in terms of asking researchers to join our projects in trying to participate in predicting which results we'd replicate using surveys or prediction markets, so to test different wisdom of the crowds mechanisms. So relying on many researchers to participate. And then we do so-called multi-analyst studies where we ask different researchers to test the same hypothesis with the same data. So all of these projects really involve a lot of researchers cooperating to different degrees. So big team science is here sort of a must. We don't really have the choice. We couldn't pull this off at the smaller scale. And of course, there are some problems that arise in these projects, but I don't think they're fundamentally different from the ones that appear in small team science. So like sometimes there can be an unclear division of labor. Who should do what? Inefficient communication. But actually taking a step back, I think we solve many of these issues maybe better for big team science projects than we do for small team science, because it's so clear that when so many people are involved, there needs to be sort of some division of labor and people need to know what they are contributing. I think sort of developing protocols, at least internally in our groups, is very useful and a little bit different from how social scientists typically work. So I think we're looking more at the natural sciences in terms of setting up these projects and communication. Results are, if anything, more credible, I think, for these big team science projects than for small team science. Why? Because here we have so many participating researchers with expertise. So instead of having one or two people doing the analysis, we can really ask a team of people to do the analysis independently, which sort of adds credibility and, I think, robustness to any of the results. So I think sort of most of the challenges related to credibility and reproducibility are really less prevalent for big team science than they are for small team science, at least in the domains where I'm sort of working.
That's really great to hear. I would like to also have a little bit of, insights coming from a funder. So, Amy, this one will go to you because I know that NWO has a specific program dedicated to replication studies. So reproducibility remains, of course, a cornerstone of credible research, particularly in the realm of big team science. So NWO launched the Replication Studies Pilot Program, aiming to normalize replication research and enhance our understanding of research replicability. Could you share some more research about, well, first of all, how did you come up with the idea of such a program? Why? What was the rationale? And then if you already have some insights as to where you are now with the program and its impact on the scientific community.
Yes, I'll do my best. So you perfectly sketched out the two aims we had with coming up with this specific calls to normalize and stimulate replication studies. And that was actually because of a Dutch scientist who posted a tweet calling out funders that there's no room to do replication studies, that there's no funding for it. So that it was back in 2015 or 16, and that got everything rolling. And we realized that the replication research is at a disadvantage in the normal funding scheme, so we maybe need to step in there. And it's also the second aim is to provide us, so the funders, more insight on what we need to fund replication research, and with the end goal of maybe mainstreaming it into our normal funding schemes. But that's a very nice end goal, but it comes with the disclaimer that we're nowhere near being able to do that, unfortunately, but we're taking steps. So we have launched 3 rounds from 2016 to 2020. And we received almost 200 applications in total, of which we could only fund 24, but it's still 24 projects. And we did an evaluation afterwards with an external evaluation committee, which provided us a lot of insight on how to continue and what to improve. And then there was a couple of years where there was some uncertainty about follow-up of the program. But with the launch of Open Science NL in 2023, we were back on track and we could launch the 4th call, which we are right in the middle of. And we adjusted some points to adhere to the evaluation committee. And I think the most interesting one, perhaps for today, is that we broadened the disciplinary scope of the call. So the first calls were only for health, medical science, social science, and then in the 3rd call also humanities. But now we open it up to all disciplines, which is a very fun but challenging thing to do. And I think maybe there were some big team science stuff I encountered myself in trying to write a call that is not so vague that nobody understands what it's about, but it's not so specific that we exclude some disciplines. So that was really fun. I interviewed a lot of researchers from different disciplines to get a really inclusive call. And I'm happy to share that we managed to include a lot of disciplines in the call, because the deadline was the 6th of March. We got 85 applications, so that's a nice number. And almost half of them are from the social science and humanities, so that's mainly psychology, of course. And a third is from the science field, so the chemistry, physics departments, 15% of the medical and health science, and then 5% of the more applied and engineering kind of stuff. So we got some nice spread of disciplines, which we're really happy about. So in terms of insights, I think it's a little bit early to really pinpoint stuff, but I think we're really happy to see, and a little bit surprised also to see that there's a lot of coming from the chemistry and physics side as well. The psychologist we anticipated, because it's a field that's been focusing on replications for quite some while now. So it's really fun to see the other disciplines jumping in as well.
Thank you. I mean, that's fantastic. And well, yeah, psychology, we would probably all guess that would be on top of the list, but it's good to see that there is also a nice spread over other disciplines. Tracy, your research is quite particular here in the context that we are here today. So it delves into a particularly intriguing facet of big team science, the role of many author non-empirical papers as opposed to traditional empirical research articles. So could you elaborate a little bit more on the unique challenges associated with this type of scholarly collaboration, and how can researchers effectively contribute to many author papers?
And thank you for that question, Agata. So many author non-empirical papers, I think, have a very valuable role in synthesizing knowledge and experience, and in particular, knowledge and experience that comes from many different researchers or other stakeholders within the research community and in sharing knowledge of a type that may not normally make it into the scientific literature. And so we have used this process to bring together people from different groups from around the world to write papers, for example, on recommendations for how early career researchers can be involved in improving the future of scholarly communication in working with publishers, or to offer 11 strategies for making reproducible research and open science training the norm at research institutions, as well as other topics. Non-empirical papers might include guidelines or recommendations, roadmaps, how-to guides, or creation of other resources that can be valuable to the research community. And we've recently shared 2 preprints, one for how to lead a many-author non-empirical paper, and the other for how to effectively be a co-author on a many-author non-empirical paper. And I'll share links for those in the chat in a minute. If you are leading a many-author non-empirical paper, one of the really important things to consider is that the process by which you integrate comments from authors and process feedback is very, very different from when you're working with a team of perhaps 5 or 10 people on a smaller paper. So one of the challenges for everyone in this process is managing the volume of feedback that you receive and the diversity of perspectives. And if you do that well, these papers can be very powerful in helping you to address the needs of many audiences simultaneously and create a valuable resource. But usually when we're responding to author comments on papers, we do it one at a time. So we address one particular comment and then we move to the next one. If you have 300 comments on your manuscript and you try to do them one at a time, you'll go insane. So don't do that. Instead, we recommend that you group comments together into things that are addressing a common theme. And sometimes things that are addressing a common theme will be clustered in similar sections of the manuscript, and other times they will be spread throughout the manuscript. Once you've grouped, we recommend that you focus first on the comments that have the potential to cause major changes in the structure and content of your paper. And you handle those comments first, because there's no point in making minor adjustments to wording in a section that you're going to cut or remove anyway later. And once you've dealt with all of the major comments that are going to affect the structure and the content of the paper, then you can go back and refine some of the more minor points. In terms of how to be an effective co-author, there are a lot of things that can be important here. The first thing is to remember that if you are the 25th or the 50th author that's going through a paper, probably a lot of the things that you would have identified, someone else has already commented on. And so you don't need to comment on those things again. You can maybe just add a +1 to indicate that you also agree with that comment. It's also important, I think authors often feel that they have to provide a certain number of comments so that the leads know that they actually reviewed the paper and were involved. And the challenge that creates on a mini author paper is that people who review the paper later, because those big things have already been identified, they'll keep looking for smaller and smaller and smaller things. And then you get more and more comments that makes it harder for the writing leads to find the stuff that's really important and has the potential to impact the content and the structure of the paper. So we would encourage you not to do that, to acknowledge that if you're the 50th author to review a paper, the major things have already been identified by someone else, and that's great. And that's okay. We're not counting the number of comments that you make or how substantive they are, because again, we would go insane. So just really redefining your definition of what does authorship mean. The other thing that's really important, I think, is to post all of your comments publicly whenever possible instead of emailing them to the leads. When you post them publicly in the document, they're part of a common discussion amongst all the authors, and people can review those and respond and have a discussion about what they agree with, what they don't agree with, and come to some sort of consensus. Whereas if you email the writing leads, now the writing leads have to decide whether they can share that information and how to share that information and how to get it into the public discussion. So it creates an additional complication. Another thing that's important to remember is what we call the golden rule of many author non-research papers. And so just think about, if you're unsure whether you should do something, what would happen if 25% or every author on this paper did the same thing? What would that look like for the writing lead and for the paper itself? So if you're thinking about, hey, I would like to add 5 citations of my own research here, or an additional paragraph on this topic that's really important for me, just sort of ask yourself, what would happen if everyone did this, and what would the paper look like as a result? So we've provided a lot of other very specific tips in the 10 Simple Rules articles, both for those who are leading a many author not research paper, as well as those for those who are contributing. And many of these papers also apply to many author papers that are original research as well. The additional challenge of the non-empirical papers is that structure and content are very difficult to determine, because the structure can be anything and the content can be anything. Whereas if you're doing a research paper, the structure is probably introduction, methods, results, discussion, and the content is your research study. So those questions are solved quite simply. But I would encourage people to check both of those papers as resources, and then I'm certainly happy to talk if anyone has questions about how to do this or why to do this or other complications involved in doing this. But it is a very worthwhile process. I would encourage people to try it. I think we really need more people who have this skill, and it is a challenging one to develop. The first paper that you're doing, you learn a lot, so.
Thank you, Tracy, so much for this. I really enjoy the fact that those were very practical tips that can actually, that researchers can use in order to, I suppose, stay sane. That was the common thread of, what you were talking about. If you could put links to both preprints that you mentioned in our chat, that would be fantastic. Kamran, moving to you. You represent an institution of a magnificent scale. So at CERN, you have vast volumes of data. They are managed by equally vast teams of researchers. So the effective coordination is crucial, actually. So I wanted to ask, from the point of view of your institution, what institutional mechanisms are in place to facilitate this, data exchange and collaboration so that it's actually seamless and effective, and how open science practices are integrated in these efforts?
Well, first of all, Agatha, thank you so much for having me, and I'm honored to be on this panel in such esteemed company. Yeah, as you mentioned, CERN is kind of the epitome of big science, and probably one of the most notable global examples of big team science. And so for those of you who aren't familiar with CERN, it is the world's largest particle accelerator facility. We're a lab, a research infrastructure located in Switzerland, although much of our facility extends largely underground, some above ground, into France as well. We are home to the world's largest scientific instrument, which is the Large Hadron Collider. And I always like to share a few fun facts about it. So it is a ring-shaped particle accelerator, about 100 meters underground. When it's in operation, the magnets are cooled to about 3 degrees Kelvin, which makes it the coldest place in the known universe. Our particle collisions take place at energies that are 10,000 times hotter than the surface of the sun. It is truly a global collaborative enterprise, entirely funded by contributions from member states that collectively contribute towards our common need for understanding of some of the very fundamental questions about us and the universe. The particle collisions are captured in 4 different detectors that exist along the span of the LHC. Each one is about the size of the Milan Cathedral, consisting of tens of millions of different sensors of some very sophisticated electronics. And when the LHC is in operation, it generates about a petabyte of data per second. And given the long run times of the LHC, we generate more data than is ever possible to be stored. So in an environment such as this, where we have thousands of researchers working in these large scientific collaborations, practicing open science and practicing effectively is an ongoing challenge. At the same time, the nature of the discipline and its complexity, in a sense, might lend itself to, might actually necessitate openness as the only real practicable way of communicating research in a discipline of this scale. So we operate and maintain infrastructures that enable the distribution and analysis of research data across the globe. So there's the worldwide LHC computing grid. And at the same time, the organization also has developed a range of different tools that allow researchers and research groups to preserve and share and reuse different parts of their analyses. So the CERN Open Data Portal being a good example, our document server, which is our institutional repository. But then we have other tools such as CERN Analysis Preservation and our reusable reproducible analysis platform called Rihanna. I can talk about them in more detail if needed. But we aim to facilitate the preservation and discoverability of particle physics materials, which addresses a central goal of our open science ambitions. And wherever possible, and all of our tools are developed as free and open source software, so that we enable their reuse by other institutions in ways that can help facilitate transparency and discoverability. Another good example of this is our Invinio repository platform technology, which is entirely open source now evolved to Invinio RDM, but which also powers the Zenodo platform, which isn't just a repository for researchers in high energy physics, but is a multidisciplinary global platform hosting data, software, papers, and is part of our kind of contribution to the global open science movement. So as I mentioned, there's this sort of ethos within our discipline, but then also sort of a practical necessity to practice openness. But at the same time, we our research collaborations do really have a lot of independence. And so we try not to impose any particular solutions for them. So they all have different sets of challenges that largely they solve on their own. What we try and do for certain cross-cutting challenges is provide some technical solutions, but our ethos is very bottom up. So I would say there really isn't a kind of single set of institutional mechanisms. What we have done in the last couple of years is through policy frameworks that through the LHC Open Data Policy and through the CERN Open Science Policy is tried to create a kind of a policy framework that incentivizes and encourages open science practices across the organization to try and harmonize everybody towards a particular vision for open science. But I wouldn't say that there was any kind of single set of institutional mechanisms in place, and because we really don't want to interfere with how our experimental teams work and organize themselves. We try and enable open science practices where possible, but we really kind of consider ourselves to be the infrastructure and there to support our large teams of researchers, but we also like for them to have independence and autonomy in the work that they do.
Thank you very much. We've heard from different stakeholders. So we've heard from researchers, we've heard from a funder, and from an institution. So I would like to keep these lenses on. And the next question is for all of you. So drawing from your experience, what is the single most important piece of advice you would offer for navigating the challenges of practicing open science in the context of big team science? And how would you tailor this advice to the specific stakeholder group that you represent? It might be a researcher, a funder, an institution. In your view, what concrete steps can researchers, funders, and institutions take to cultivate a transparent, collaborative, and effective large-scale research environment? Who would like to take it on first? Cameron, go ahead.
Sure. And I only jumped in first because I have a goldfish memory and would have completely forgotten that question. So I think at least from our point of view, much of the time, the research community, as much as they like open science and their values align with open science, many open science practices can feel a little bit burdensome to them, like an additional responsibility on top of all of the existing responsibilities they have in their research work. So to the extent that we can, we try and lower the barrier for them. And if we can do that through technology, that's sort of one solution. And there's some ways that we try and do this. For example, when it's something really simple, when a researcher comes to CERN for the first time and they register themselves with the user's office, they have to provide an ORCID. And so already that's kind of like a first step in getting somebody to have a persistent identifier that then they can use to associate themselves with whatever research outputs they're going to produce during their time at CERN. But then another tool that we have developed, which I mentioned earlier, is called CERN analysis preservation. It's a technology that's used across some of the CERN experiments and very successfully across the compact muon solenoid, which is one of the four large experiments, CMS, it's called. And at CMS, they use CERN analysis preservation as a kind of integrated, holistic platform. So what that means is that when a research team wants to perform an analysis on a data set, they have to fill out a form where they propose to the collaboration what they want to do with that data set. And that form is hosted on CERN analysis preservation. And so right from the very beginning of a study, when someone even makes their proposal, that's captured in the platform itself. And then throughout the research lifecycle, whether they're using Jupyter notebooks or whatever software they're using, that's all integrated into CERN analysis preservation. And this all actually happens in a closed environment. So only when a research team is finally ready and satisfied and willing to sort of publish their analysis, they can kind of click a button and all of those different aspects of a research analysis are then captured for them and assigned persistent identifiers. And so now our open data policy and our open data portal, when we make data available, we don't just make a data set available. Making, you know, one of the CERN data sets of just available on a platform likely has very little value in and of itself, unless you provide all of the contextual information, the software, the computational environments, the Jupyter notebooks, and maybe even the, you know, the very research proposal from the very beginning that can allow somebody else to then extract scientific value out of that data set. So we don't just release data, we try and release all of the contextual information around a data set. And so that really kind of, to us, is a way of really kind of, you know, lowering the barrier for researchers so they don't have to be thinking about open science right from the very beginning, which, you know, hopefully the cultural change will shift and people will start doing that. But we're doing our best to try and lower the barrier through technology and to make that possible. And just one other thing to mention is that our reproducible analysis platform, Rihanna, with that, what you can do is once all of this information is available on the CERN Open Data Platform, rather than having to download everything onto your own computer to perform, you know, your own level of analysis, what you can do is you can create an instance in the cloud. And imagine our data sets are pretty large, right? So you probably don't want to download all of that onto your computer. You can create an instance of an analysis in the cloud, instantiating the software and the workflows, and rerun the analysis in the cloud yourself to check for its reproducibility. So we try and you know, provide technological solutions to solve some of the open science opportunities that we have in a data-driven computational discipline like ours.
Thank you, Kamran. Who would like to go next? Which perspective? Anna, go ahead. So as
I'm
a
happy.
researcher.
Yes,
Yeah?
okay.
Okay.
So maybe I have a very positive take in general on all of this, but I think
That's great.
open
We need some
sciences-
positive. Yeah.
So I think open sciences practices basically almost only help in the workflow. When you pre-register and you have a pre-analysis plan that you can transparently follow. So I think most of these practices makes it so much clearer what is going on. So both for participating researchers in these projects, but also for future readers of these papers. So it's sort of easy to forget all the choices one makes when the sort of setting up a project, any, not just replication projects, but any type of research project, right? Because there are so many choices to make, and you forget why you went down one specific path in some garden of forking paths and not another. So all these open sciences practices, I think, make this more transparent and makes it then easier to replicate studies, extend projects, understand sort of why certain stimuli were chosen and not others when you're trying to directly replicate, conceptually replicate, etc. So I think if we were documenting even more sort of how a research question evolves to specific hypothesis, that would also make it even better for everyone involved to understand what's going on. So I think the biggest challenge is maybe not open science related things to big team science, but more related to funding, promotions, like how are these projects evaluated when you have so many authors, and is it always clear who did what, etc. And then there are sort of clear practical but more boring issues related to, for example, making it smoother to transfer research money across labs if these are big team projects where you are replicating things in many labs at the same time. How should we think about ethical approvals? Do we need it in every specific country or lab? Or how can we facilitate things like this to sort of lower the barriers of entry for those that want to do big team science? But I mean, to summarize what I said, I think the open science practices are, in my world, only facilitating making this possible. And I think that, of course, adds also credibility to the specific empirical results we end up getting from our p-values, etc.
Thank you so much, Anna. Ami, I will go to you because Anna also mentioned funders. So
Completely agree.
go ahead.
Yeah, that was what I was thinking. I was thinking from a funder's perspective, I think it's essential that we try to get some sort of incentive for open science practices and reward people who engage in open science practices, in the big team practices. So that's something that Open Science NL is trying to do in the Netherlands. And I think what also was important for me in setting up the replication study call was really do it in close conversation with the field, and not as a funder decide what the researchers need or don't need, because we're not able to fill that in for them. So really try and communicate with each other and get input and insights from the researchers themselves. Yeah.
Great. Speaking about input from researchers, Tracy, over to you.
Yeah, so I mean, I think our other panelists have provided a number of really interesting perspectives on the question. To me, what resonates is the need to rethink our processes about what scales and what doesn't scale. And when things don't scale from 5 researchers to 50 or 100 or more, what are the processes that we need to put in place to help researchers to engage more effectively with open science, or with creating the types of resources and doing the types of work that they want to do? And once we have everyone working together, I think the other thing that's really important to recognize is that these processes require sustained interactions over time. They're not simply a one interaction and then done. If you think about the interactions over the life cycle of a research project, which will then evolve into other future researchers' projects, or if you think about a non-empirical paper where we bring a lot of people from all different communities together for content generation events, and then we're getting feedback on outlines and on a first draft and on subsequent drafts of the paper. And each time that we have communities coming together and sharing and giving information, the content is changing and it's improving and it's evolving over time. And so looking very specifically at our processes, at when do things scale, what parts don't scale, and how can we put procedures in place? How can we get people trained in those procedures? And then how do we make sure that we have the sustained interaction and involvement that we need to really develop these ideas and take advantage of this community that's very difficult to create to begin with over time, to enhance the quality of the research that's done and the openness of the research that's done.
Thank you so much. Well, I think that we've heard so many interesting insights from different stakeholders. We have several threads here. We will open up the floor for questions from the audience, and I am looking into our Q&A, and there are already 2 questions there. So I will start with these 2 questions. Also, if you feel comfortable with just asking your question rather than typing it in, just raise your hand and I will just unmute you, and we can, I mean, this is a conversation per se. So yeah, go ahead. Tracy, I think that the first question is actually connected to what you were talking about. So I will just read it out loud. It seems to me that these practical tips or rules seem to be designed to inconvenience leads less, so they stay sane, rather focusing on a participatory environment. This is particularly odd since the author seems to be aware in their preprint the need for diversity, equity, and inclusion in science. Could you comment on that, Tracy?
Mm-hmm. Yeah, so I don't think it's about inconveniencing leads less. I think it's about setting up an efficient system for communication that makes it easier for all of the co-authors to be engaged in a discussion with each other, and to get a sense of what things are really fundamental in shaping the paper and what things are more minor adjustments. So our process, actually, we spend a lot of time bringing together a community of people from many different countries, areas with different expertise. We've set up a format for content generation that's a virtual unconference format called virtual brainstorming events, where we bring people together asynchronously online for virtual meetings and then 2 days of discussions on a discussion board that goes around the clock to make it really easy for people to participate at whatever time of the day works for their life, their schedule, and their time zone. And then, as I mentioned, we also get iterative feedback at each phase of the writing process, including on the outline and on the first draft and subsequent drafts. And we usually see major changes in the structure and the content of the paper between the outline and the first draft, as well as between the first draft and the second draft. I think this is unquestionably a lot of work for leads, and anyone who has led this type of a paper will tell you that. I think there's tremendous value in taking it on, and I have no doubt that every time we have done it, the quality of what we have produced has been so much better and so much different than it would have been if we just had 5 people writing a paper. But we also realized very quickly that the amount of work and the amount of information that was being generated was overwhelming. And so if we wanted to get to that end result of having something to share with the community, we needed to very carefully think about our process, about those things that were scaling, those things that weren't scaling, and how we could adapt it so that we were working more efficiently and we were all communicating better amongst the co-authorship team. And then we needed to, we were asked to share the process that we were using with others, right? So we got requests from others to say, what is this unconference format that you're using? We'd like to implement this. We would like to use it to write papers. How are you doing that process? And when we started talking to other people who were leading these types of papers, a lot of them said, yeah, we have to do this. We really don't know what we're doing. So any advice that you have that you can share would be really helpful. And this is exactly the type of experience-based knowledge that I think comes out of non-empirical papers that you're less likely to find making it into the research literature. And I think that there would be great value in sharing these types of process adaptations and methods knowledge that authors and scientists are creating with other aspects of big team science.
Would anyone like to add to this one? If not, then I will move to another one because this one seems also quite interesting. So we talked a lot about open science practices here. So we have a question. Thank you for the interesting insights. Do you encounter some sort of resistance from researchers when it comes to open science practices? And what are some of the most frequent misconceptions and how do you address those? That's a huge question. Any takers? Cameron, did I see your hand? No. Okay.
I guess I can say something. So I move around.
Go ahead.
So I move around in the social sciences, and it's interesting to see. I think the sort of the attitudes towards open science, pre-registration, etc., are way more positive in psychology than they are in, for example, economics. And I think it's partly related to fairness. So it's easier to have a pre-analysis plan, a credible pre-analysis plan if you do experiments. And that should apply, I guess, to most sciences. But there are also, of course, costs, and people perceive that there are costs involved in sort of time use and energy, etc., to write pre-analysis plans. Plus, and this has nothing to do with big team science, but just science in general, if you have a detailed pre-analysis plan that you also intend to follow in your paper, everything else equal, you're more likely to end up with a null result because you haven't kept the researcher degrees of freedom in how to do the analysis. So there's sort of a worry that you will get more null results. They're harder to publish. So if you are in a field like economics, like me, where you have some people who do experiments and can write pre-analysis plans, and then other people who work on registry data, natural experiments that only have happened once, like Germany was only reunited once, so that's not something we can repeat and study again. We can't impose or even very much encourage pre-analysis plans most of the time for such research projects. So then they have a sort of a good excuse for not engaging in some of these practices. And then those that can engage in them feel that this is unfair. Why are you imposing these burdens on us making it potentially harder to publish. Whereas sort of the parts of the social sciences where we think that there are the most credibility problems because of more degrees of freedom in how to do the analysis, because of sort of the promise of replication not hanging over, they can just continue with business as usual. So I think that's something we need to consider. And I mean, I say that as a big proponent of pre-analysis plans, etc. But I think we should think about then other ways to assess credibility and encourage open science practices beyond sort of lab experiments, psychology, etc., to make things more fair.
Thank you so much. I will move to another question because we have more, and for the sake of time. But of course, if any of our panelists, if you would like to address these questions later, we can do so and then send around our answers. There was an interesting question here, which is also one of these huge questions. So, isn't all science inherently collaborative? If you disagree, what makes collaborative science more challenging if we are looking at open science practices? Any takers? Kamran, go ahead.
Well, I feel like I already touched on this notion, but and certainly science is and should be collaborative. In my mind, when we talk about collaborations, as I mentioned at CERN, we have research collaborations that consist of thousands of researchers, and so the challenges of enabling effective open science practices across collaborations of that size, I think, do present sort of unique challenges related to scale.
Kamran, since we have you on, there are two more questions, especially for you.
Sure.
So we have one coming from Jeroen Zondervan, and so it's about the Rihanna platform tool.
Yeah.
So the question is this platform engaging with publishers or journals, considering integrating reproducible, interoperable workflows?
I will say not that I know of. I do know that the Rihanna platform is now being scaled to disciplines outside of high energy physics, but the platform is entirely open source. So if a journal was interested in using it, they are welcome to.
Okay, perfect. We have one more for you. You are in demand. So the question is, how does CERN engages in citizen science, and what are some learnings to share with other institutions that are more closed to this concept or this practice?
So this is an excellent question for which I do not have a particularly satisfying answer. I think because I think the reality is that the size and complexity of high energy physics as a discipline makes citizen science sort of quite challenging. There was an initiative called the LHC at Home by the Atlas collaboration that was piloted a couple of years ago. I think is still is still in operation, but it's essentially an opportunity for scientists, citizen scientists, to have access to certain data sets, open data sets from CERN, and to run different kinds of analyses on those data sets. But I will say that citizen science, of all of the different pillars of open science, is one in which we probably need to put more energy and attention. I will take this opportunity, so this isn't necessarily citizen science, but to plug the CERN Science Gateway, which is kind of our new public engagement space. It's at the CERN campus, at the entrance to the CERN campus in Geneva, Switzerland. It's a really cool museum exhibition space, but it also hosts we host school kids and workshops, and have different kinds of opportunities for young people to engage with, you know, particle accelerators, and to learn the fundamentals of particle physics. There's also some really cool artistic interpretations of some of the fundamental science concepts that have come out of CERN. If anyone has the opportunity to visit, I think it was the CERN Science Gateway was either this year or last year ranked as like one of the top 50 places to visit this year. So come and check it out. And yeah, but to say, you know, that's not necessarily citizen science, but is a part of our kind of public engagement strategy in science.
Thank you so much. We are running out of time, so this is now your last chance to ask a question. If there is something else that you would like to ask our guests. I don't see any more questions coming in, and I don't see any raised hands, so I think I will call it. Thank you so very much. I think that we've all learned a whole lot today, starting from an optimistic view from Anna, who said that if anything, big team science is actually perhaps the type of science where openness is the most important and facilitates good research, pretty much. We also heard that for once, social media did something well, because it was thanks to a tweet that NWO decided to come up with a call for replication studies. And we also heard some very practical tips that we can use in this environment with lots of authors. I also very much enjoyed Kamran's tips for all of us, telling us that we should go to Switzerland pretty much. So I think that this is what we all should come out with from this session. Let's book our tickets to go to CERN. Thank you all very much. We will meet for the 4th episode of the PLOS Open 2.0 series in late June. And we will most likely talk about what pretty much everyone is talking about now in the space of open science, which is what? Diamond open access. So let's see. Thank you very much. I will be sending around a link to recordings and also links that were in our Q&A to all registrants, so that you can, if you didn't have a chance to click on them now, you will have the chance to do it later. Thank you so very much. Yes,
I guess a final plug.
Yes.
Where
should we go?
I'm really shameless. I'm sorry. But if it makes it more appealing, we are at the CERN Science Gateway from September 15th to the 17th, hosting Open Science Fair in partnership with Open Air. So it's a 3-day conference on the importance of collaboration in open science. So for those of you who are interested, look it up and come join us, and you get to visit the Science Gateway at the same time.
Fantastic. Thank you, Kamran. So Kamran organized our September for us. That's good. Thank you so much again. Thank you to all speakers, to audience, and I will see you in late June for the next episode of the series. Thank you so much. Goodbye.
Thanks, everyone.
Bye.